Hey there, cool kids. So in this video, we're gonna be talking about waves and the different kinds of waves. So there are two different kinds of waves. The first kind of wave, transverse. So transverse waves are the tall up and down wave. And that's actually my first trick I wanna show you is the tall transverse wave. So T, this guy right here, my little trick to remember is that it is a tall wave, okay? Whenever you're looking at that, that's that up and down looking wave, right? That tall transverse wave, all right? An example of that is a light wave or an ocean wave, which I've also drawn up here and is quite cute. Just saying. All right, so you've got your transverse wave. The other kind of wave that you have is your longitudinal wave. So the longitudinal wave, the trick that I like to help remember for your longitudinal wave is that it is the long wave. Okay, it's longitudinal, it's really long. Okay, it doesn't go up and down like that guy, it just goes long ways. So here I'm going to show you an example. So like an example is slinky or a sound wave. So I'm going to show you my slinky wave. We got that compression and then it's spread out, that compression again, and then it kind of spreads back out. Okay, so the other nickname for the longitudinal wave, the long wave, is compressional, because right here and right here, you see those compressions happening. So compressional. Compressional wave. Compressional wave, longitudinal wave, same thing if you ever hear that. And again, your examples are your sound and your slinky. So speaking of slinkies, ta-da! Okay, I'm actually going to demonstrate to you a longitudinal wave and a transverse wave. So this, my slinky is going to be my longitudinal wave. My rope is going to be my transverse wave, okay? So first I'm gonna do the transverse wave as best I can. So I'm going to flick it so that it goes up and down. Hopefully you saw that wave, and it was a little fast. There it goes, up and down, my tall transverse wave. Okay, now one thing I want you to notice is that as the energy, because I am physically moving the wave, okay, my energy from my hand is going into this rope and transferring all the way down to the other end. That's what a wave does. The whole point of a wave is that it transfers that energy. And it doesn't move the matter stays still. So this piece of tape right here is actually supposed to symbolize the matter going back to the same place that it was originally. So if you look again, watching that piece of tape, it will move up and down, but then it will go back to its original spot every time. Same thing with your longitudinal wave. So my handy dandy slinky here, I'm gonna stretch it out, and you're gonna see that it has that same tape on it, okay, that same piece of matter that you can track, and I'm gonna send a wave through my slinky, send that energy through. You might not have seen it, let me try again. This one's a little bit harder to do one-handed. Okay, and release. There we go, that was a little bit better. I'll do it again just in case you didn't see it. So I want you to see how the coils compress and then they spread back out. Here we go, ready? Okay, well hopefully you saw it, but there it is. Okay, it's long, it goes back and forth, the longitudinal wave. And again, this guy right here, after the energy passes through the matter, goes back to the same original position, because waves transfer energy, not matter. Okay, the last thing we're gonna do is I'm actually gonna label with you a wave, its parts. So we're gonna go to this transverse wave because oftentimes we label the transverse waves. So the first thing about the wave that you need to know is this middle line right here. Okay, when you jump into or actually right before thinking about summertime, you jump into a pool and nobody's touched it. It's completely still and completely flat. You're the first one to dive in and send your energy moving through that water, going up and down. So before it starts moving up and down like that, that flat is actually called equilibrium. Now, let's just say you dove in and you jumped back out of the pool, and after a really long time, what happens to the water? Does it keep going in a wave? No, it eventually goes back flat, okay? And that flat is called equilibrium. I'm just gonna draw a little equal mark right there so you remember that is equilibrium, okay? All right, so that center line is equilibrium. The top of the wave is called the crest, and my trick to remember that is the crest is the best. Crest is the best. Okay, draw you a little crown because it's the best. Okay, crest is the best. Down here, this bottommost portion, that is the trough. And the trough, I don't know if you knew this, but pigs, that's what pigs eat out of. That metal scoopy looking thing, kind of looks like, you know, that, where they put all the rotten vegetables or whatever nastiness pigs eat. That is a trough. So the trough, my trick to remember trough, is it's what pigs eat out of. It is the lowest of the low. My little piggy. Let's see. Give it some big old ears. This is probably a horrible pig because I'm not a very good artist. But that's okay. So trough is what pigs eat out of, and there's my little trick to help you remember. Crest is the best. Trough is the lowest of the low. Okay. The next part of the wave is your amplitude, which is always from equilibrium to the top, or you could do from equilibrium to the bottom. But either way, both of those points, or both of those distances, is your amplitude. All right. One more is going to be the length of the wave, which is called the wavelength. I know it's really obvious. You don't really need a trick for that one. At least I really hope not. But anyways, so the length of the wave is from 2 consecutive points, which means 2 of the same points on the wave. So you can either do it from crest to crest, and that is your wavelength, okay? Or you can do it from trough to trough. So boom, boom. That can be your wavelength, okay? But what you can't do is you can't go diagonal. You can't say, okay, so from crest to trough. Yeah, that's a no-no. Oh, we don't do that. All right, so that would be your wavelength. One more aspect of the wave before we conclude our wave session for today is we need to talk about frequency. Frequency is how often a wave occurs. So if I have this wave, okay, this is my wave, and I have this wave. Okay, so clearly the wave on top is not happening nearly as often as the wave on the bottom. So that would be, you would say that the top wave has a lower frequency than the bottom wave. Or you could say it the other way around. The bottom wave has a higher frequency than the lower wave. And how you remember frequency is you can say, frequency is how often something happens. So, how frequently are you turning in your homework? Or how frequently are you sharpening your pencil? Whatever that it is, but it's how often it occurs. All right, that concludes my spiel on waves. Hope this helps. Be seeing you later. Actually, that's a lie. I won't be seeing you later, but you'll be seeing me later. Deuces.